Yeah, hello everyone. I would like to start with a short overview about BASF, especially BASF Performance Materials Division, because I think it's quite interesting for you. So Performance Materials Division means we are talking about all plastics or all foams, everything what is produced in BASF. And in this division, we have, I would say, very interesting service. It's what you see here on this slide. So all our customers who buy the material get additionally a simulation service. This is mainly used for getting in a very early development stage information if a part is possible to produce, or if, for example, in the right upper picture you see how the part fails. So we get a huge amount of information very early. So, and this is, I would say, that's the current status. That's what we offer since many years, and what we do as a daily business. So, and these high-end FEA support for the customers. But then we saw during the last years that sometimes it's quite hard to explain what we are doing, especially because we are talking most of the time about 3D results. So if you discuss 3D results on a 2D screen, you lose information. So this is, I would say, the industrial standard. So every one of us engineers has 2 screens, and there we discuss about results. But we thought about, okay, if we have complex shapes, complex geometries, what could we do to make the understanding better, to make it easier for the customers? Because sometimes we have very detailed discussions about it. So our vision was to combine mixed reality with our high-end FEA support to make it easier to understand what's happening in a part, to make it to take the customer more and more into account, to make it also, I would say, more as an experience for a customer. And one big point is for us the multiple device setup. So we talk about, like I said, I think I use the customer word very often today. So if we talk about customer, we talk about a shared experience. So, and then we collected the points. And so, okay, one of the problems we have is that we use a huge amount of different simulation software. That's what you see on the left side. So all these different simulations program has an individual file type. So the first requirement from our side was we need a standard, so a definition. And therefore we decided to develop based on the VTK format. VTK format is one of, I would say, good documented open file formats. The second point is, you see it on the picture, the multi-user functionality. So if I talk about customer interaction, we need more people together to discuss about one setup or one application or one part. So this was also, I would say, a requirement from our side, very important requirement. And the third big point you see here on the screen is standard post-processing features. That's what you could do with every normal simulation program. You could change the plot colors, you could animate time frames, you could rotate the part, you could scale the part. So that's defined by standard post-processing features. And with this idea or this vision, very happily we came in touch with Holo-Light. So we met us, I think, at
a year ago.
Yeah, more than 1 year ago, and yeah.
Okay, thank you, Patrick.
Thank you.
So Holo-Light. Holo-Light is a mixed reality startup which has a focus on developing key technologies for industrial applications for augmented reality. So in the last years, we have focused on 3 main stacks where we have found certain problems which are worth to solve. The first one, which is here, the remote rendering, is if you look at all the devices, they are limited. We have limited power in CPU, in memory, in GPU, and somehow, especially for industry, you need to solve this. And here we have the focus to outsource computing power. The second stack is for interaction. Currently, there is no unique interaction for all those different devices. And here, with our Holo Stylus, we made a very nice and intuitive solution. For those 2, I will come later in more details. And the third one, the collaboration framework for us means how do we interact in a team together to work on a more experienced way in augmented reality. And we think this is one of the most important parts for industry. And approximately a year ago, we met Patrick and Helge from BASF at the Startup Autobahn accelerator from Plug and Play, and we presented them our collaboration tool Holo-View, which is focused on CAD collaboration, so CAD. For example, you have in a meeting room an engineer, a marketing guy, and a management guy, and they are communicating and talking about the latest new feature in an engine or a similar thing, and they want to better understand it. And we think that augmented reality and our product Holo-View is the right to solve this thing. But BASF needed a small additional feature, which means we have to implement not CAD files, we have to implement CAE files, so computer-aided engineering. So the cool color plots you saw before with all the nice colors and things which have some physical meaning or properties, which are pretty complicated and only the specialists can understand. But we said, okay, we can do this, and we developed this technology and this product. So with a very tight time frame, we released our first prototype at the BASF customer event, approximately 5 months after our start, and presented the first results. And afterwards, we focused mainly on the development of the core features, like Patrick said before, especially the multi-user, so that different people from different spots can see the same holographic object with the same orientation, so that they can discuss in a detailed and precise way about the object. Also, as said before, we have the VDK file format as our standard support format, so you can almost convert every type of CAE file from ANSYS, Abacus, and so on in this file format, and then present it on a smart glass. And yeah, with a development time of approximately 13 months, we were able to release our first MVP of Holo-Simulate and have fulfilled all the demands BASF gave to us.
So in here I have a few more, I would say fewer applications from us to make it better understandable why we do this or how we use it or what we need. So here you see this is the part is called the elbow, so it's a 3D printed part. And here you see one benefit what is very important for us, so we could take other physical parts into account. Like Alex already said, think about you in a meeting, sitting in a meeting room, you just place the part on a table and yeah, you continue your discussion. So you also see the different colorings, so in this case the white coloring and also the red and white and blue coloring. So this means here in this case that you see on this picture the different time frames. With the different time frames, we normally see the different stresses. So in this case, the engineer would look, okay, there are red areas. Red areas look more critical because they have higher stresses. So we would focus on details and see how we could fix the problems. The second point is the manipulation. That's what I already said with the word of standard post-processing features. That's scaling, moving, rotating. So we are very free, I would say, to move the parts and place them anywhere in the room. And this is a good function. Especially here you see an engineer would focus on the different colorings and also on the vector plots and see how the material locally, what kind of local properties you have. So this is the second big point. And the third point, what I think is most important is the multi-viewer or multi-user function. So I would say in every meeting we are talking minimum about 3 or 4 people. So most of the time it's the second development engineer of our customer, and very often also one of our colleagues from sales or another sales colleague from the customer. So we are 2 or 3 people minimum sitting together and want to discuss about the same part and the same application. And here you see it quite nice that we also had an additional physical part without the coloring, which we could take into account. So this is quite important for us from the functional side. So, and as a summary from this, from the technical point, I could say as I already said, the view of the original size in these applications you saw, I think it's quite easy to understand it, but think about, we also talk about applications out of plastics which are 1 or 2 meters big. So in this kind of application, it's you can't take the original size if you have just a small screen in your office. So this is a big benefit for us. The manipulation, like I already mentioned. I think the third point is also quite important. Take physical parts into account, because very often we are talking just about one part in a whole setup, and there it helps sometimes to take also other physical parts into account. The point number 4, the portable solution. Sounds quite simple, but it's not all the time our customer could come to our BASF office, so sometimes we also have to go to the customers, and for a presentation or something like this, it's quite easy, because with the HoloLens at the moment, so that the development is mainly used with the HoloLens at the moment, so it's quite easy to take it in the hand luggage and fly wherever you want. And also the multiviewer mode, I think it's the point I said, it's quite important. So, but we also saw a few points which are critical. I mean, the feedback was mainly by talking to colleagues and doing a first implementation. So the memory and CPUs, what we saw, especially on big FEA models, is quite complex to handle. So we are limited at the moment. The same point, I mean, all of you know it, it's a field of view. It's more hardware point. So, but for me, it's quite okay if I take the glasses. But if you have someone which is not familiar with this topic, the first sentence is, why could I see just a little bit? So that's, I mean, also a point. The battery capacity and the weight is also a big point. I think we talk very often in detailed discussions about several hours about one part or one application, and you all might know it, there we are limited. So I could say from our side, we try now to implement this more and more to our daily work, also to the work together with the customers. But at the moment, I would say it's not standard. So that's, I also have to say, because it takes some time to prepare the models, upload them, and but we see that most of the problems we have at the moment will be solved in future due to technical development, because you see how far everything is getting developed. So we see that there might be good opportunities in future.
Exactly, and one of those problems, as I mentioned in the beginning, outsourcing computing power, we want to solve with remote rendering. So take a laptop or a server, put there the big files. They can vary from several gigabytes to tens of gigabytes or more, and render and compute the whole thing on the server or the laptop, and then stream it on your smart glass, on your mixed reality glass, and then you still have the experience of augmented reality in this industrial area. And the second problem we want to solve, the interaction, because if you look at all the glasses, you have no standard input. Let's say the Microsoft HoloLens has a gesture, DAQRI has gaze only, HTC and Oculus, they have controllers, but the missing thing is like the mouse for the computer. And we came up with the idea 1.5 years ago and thought about a pen, a simple pen which you hold in your hand with 2 buttons, and you interact very precisely in a very accurate way through our artificial intelligence-based tracking system to get an millimeter accuracy, and therefore you can release a whole new concept, a whole new variety of use cases. And it's also the first time really possible to create content in an industrial way.
So, and also one more slide, one final slide from my side, what's next in BASF. So we continue our work together with the customer, and we want to get the real world and the virtual world closer together, especially our material world in BASF, and therefore we built a BASF Creation Center. And this is a completely new concept to collaborate together with the customer. And if you are interested in one of these topics you've seen today, so feel free to send me an email if you're interested in an internship or something like this. So we definitely continue this work in with a digital environment.
Okay, then also I want to thank you for coming. Thank Patrick for this cool experience together with BASF. And please visit us at our booth downstairs. You can try out all those things. You can try out our remote rendering, our stylus, and also talk to us about the use case and about how we did it and what's our plans for the future.
Thank you.
Thank you guys so much. We do have some time for questions if you're open for that.
Yes.
Yeah.
Are there any questions from the audience?
Just a quick question regarding the pen and what you experimented with before that. Did you do any other tracking methods, like even something like leap motion attached to a HoloLens, or anything that would give you hand tracking?
No, we skipped the leap motion. Of course, we have experience with leap motion, but we skipped it. And we thought directly that for an industrial usage, you need something in your hand. Only gesture is still something not that intuitive, and sometimes you need some additional thing where you can control and also can have an feedback, so that you did something and you get some vibrational or tactical feedback in order to feel, okay, I did the right thing, or I am now in the right position.
Okay, thank you.
Any more questions from the audience?
I've seen that you've put in the digital mockup with the FEM results and the physical mockup as 3D print separately. Did you try to map the results, just the colors, onto the real stuff, so that you track the object by itself?
Not
yet.
Yeah,
Not yet.
Not yet. No.
Because of what? Not because why? Because I think it's very strange. You have the real part, yeah. You had a simulation of the real part, and afterwards you put the digital results on the right side of the real one. So
I could understand this question. The point is, in most of the cases, you do not have the 3D printed part. In this case, this elbow was a part which was designed and printed by the BASF 3D printing solutions. So they are focused on material for 3D printers. So in this case, we had luckily the part, but normally we very often use injection molding process, and then we do not have any part in this stage.
And a short second question: you've showed this pointer. Do you need an extra tracking unit to get the pointer, or do you want to solve it by the HoloLens itself?
So therefore, we have two goals. The short and medium term goal is we have, because also of our startup stage, we have this prototype thing, this sensor thing, which is on the device. And it also gives us the possibility to mount it on every other device. So we are independent of this device through the head-mounted module. Because, for example, an Oculus or an HTC, they don't have infrared cameras, which we are using. So therefore, it's okay to put it onto the other thing, and also reducing the weight. You basically don't think that there is something.
Okay, thank you.